Welcome all, I am T.Y.B.Sc from SSR College Silvassa. In this tutorial, we will talk about problems on continuity part 2. How to use this video effectively. This video can be effectively used if students write down the contents of tutorial in a notebook, read it 2-3 times and then follow it from video. The contents of tutorial is available in PDF with title Problems on Continuity Part 2 on the following link. Continuous function. Let xt and y row be matrix spaces and f from x to y be a function. We shall use the following equivalent statements to prove a function is continuous or not at x0 belongs to x. First, f is continuous at a point x0 belongs to x if given epsilon greater than 0, there exists a delta greater than 0 such that if x belongs to x and t distance between x and x0 is less than delta implies row distance between fx and fx0 is less than epsilon. Second, f is continuous at a point x0 belongs to x if the sequence fxn converges to fx0 for every sequence xn in x which converges to x0 in x. We say f is continuous on x if it is continuous at each point x0 belongs to x. Example 1. Let Ru be usual matrix space and f from R to R be a continuous function. If fx is equal to 0 for all x belongs to Q, the set of all rationals, prove that fx is equal to 0 for all x belongs to R. Solution. Let x belongs to R arbitrary. As Q is dense in R, so for each n belongs to n, there exists xn belongs to Q such that distance between xn and x is less than 1 by n. Consider this sequence xn in Q, then xn tends to x. As f is continuous, this implies 0 which is equal to fxn converges to fx. As fxn is 0 constant sequence, so it will converge to 0. Hence, fx is equal to 0. As x belongs to R arbitrary, we have fx is equal to 0 for all x belongs to R. Now recall, let xt and y row be matrix spaces and f from x to y be a function. Then f is continuous on x if f inverse g is open in x whenever g is open in y. Using this, we have example 2. Prove that f from xd to y row, where xd is a discrete matrix space and y row is any arbitrary matrix space, is continuous. Solution. Let G be an arbitrary open set in y row. Then f inverse G is open in xd. As inverse image of arbitrary open set in y is open in xd, hence f is continuous. This is because any subset of discrete matrix space is open. Hence we have f inverse G is open in xd. Hence f is continuous. Example 3. Let xt and be matrix space and y xt be a matrix space and y contain in x. Prove that the identity function I from y cross y dy to xd is continuous. Solution. Let x0 belongs to y arbitrary. Let xn is a sequence in y such that xn tends to x0. That is, dy xn, x tends to 0 as n tends to infinity. Then d of I xn, I x0 which is equal to d of xn, x0 which is same as dy of xn, x0 tends to 0 as n tends to infinity. Hence, I is continuous at x0. As x0 belongs to y arbitrary, hence I is continuous. Example. Let xt be a matrix space and k greater than 0. Define the matrix dk on x by dk xy is equal to k times d of xy for all xy belongs to x. Prove that first I from identity function from xd to x, dk an identity function from x comma dk to x d are continuous function, where I from x to x is identity function. Let x naught belongs to x arbitrary. Let epsilon greater than 0 be given. Then dk x comma x naught less than epsilon if and only if by definition k times d of x comma x naught less than epsilon if and only if d comma x comma y is less than epsilon by k. Now for first, take delta is equal to epsilon by k. Then if we have dxy less than delta, then dk ik comma I x naught is equal to dk x comma x naught, which is equal to k times by definition x comma x naught less than k times epsilon by k, which is equal to epsilon. Hence I is continuous on x naught. As x naught belongs to x is arbitrary, so I from x comma d to x comma dk is continuous. Second, take delta is equal to k epsilon. Then if dk x comma y less than delta, then d of ix comma ix naught, which is equal to d of x comma x naught, which is by definition 1 upon k dk x comma x naught, is less than 1 upon k times epsilon k, which is equal to epsilon. Hence I is continuous on x naught. As x naught belongs to x is arbitrary, so I from x comma dk to x comma d is continuous. Example 5. Let xd and y row be matrix spaces and f from x to y be a bijective isometry. Then f is continuous. Solution. A function f from x to y is called isometry if distance between x and y is equal to row distance between fx and fy. That is, distance between the points x and y is same as distance between their image points. Let x naught belongs to x arbitrary. Let epsilon greater than 0 be given. Let delta is equal to epsilon. The d of x comma x naught less than delta, then rho of fx comma fx naught, which is equal to d of x comma x naught less than delta, which is equal to epsilon. As x naught belongs to x is arbitrary, so f from x to y is continuous.